doesn't really tell us what this data is about, so we're not going to label it because I don't know what it's about. I just came up with some numbers. All right. First off, what is our mean of our data here? The x bar is another way to write that. Yep. What number here is going to be our mean?
The 100.
Good. How do we know it's going to be the 100? It's at the highest point. It's in the middle. In the middle of our normal curves are mean, median, and mode. So our mean is 100. Beautiful. I want to know, what is my standard deviation? So how are they counting our intervals here? And this one should be a little bit easier because we started at 100. And to get to 115, we have to add what? 15. Yep, this one's a little bit more straightforward. But we should just double check that. Is 115 plus 15 130? Yep, 130 plus 15 is 145. Okay, and then just double check it on the other side. Minus 15, 100 minus 15 is 85. Minus 15 is 70. Minus 15 is 55. So our standard deviation is 15. All right, now we're going to have two questions with this one. My first question is, what percent of the data is less than 85? So when I look at this and I'm looking at data that is less than 85, I'm going to look at my point here where I have 85, and I want everything that is less than that. So do I want to go to the left or to the right? To the left. So I'm going to go to the left, and I'm shading in all that space. Under the curve is how much percent of data total. That 100% is all under that curve. But I want to find out how much are just these three parts. And I have these two standard deviations here and this part. So to find that, we can just flip back to N3. Here you go. Here. So we can fill in each of those spots. So to start off with, I always like to start in the middle because those ones are a little bit more easy to remember. 34 and 34. So if you want to write those in, you can. 34 and 34. That's within the one standard deviation. Now if I go to the second standard deviation, what else do I have? 13.5. And 13.5. 2.35. You are so far ahead. And it's symmetrical, so if it's on one side, it'll be on the other side. And then that last little space, remember this last little space is more than 3 standard deviations away, and that's our 0.15. It could be anywhere past that. So if I'm looking for a data that's less than 85, I'm looking for all the space that I have colored in blue. And in this first part, between 70 and 85 is 13.5% of our data. I'm going to combine that with the amount between 55 and 70, 2.35. Give me 2 seconds here. And then I want that spot that's below 55 because all of this is less than 85. No. Why doesn't she just fill up your water for you while she's gone? Alright, so we're going to add those together using our handy dandy calculator. 16, I think. 13.5 plus. Okay, 1 second. And yep, we get 16. You're literally going to miss, like, we have 3 more minutes of notes.
It's okay, I'll just use your notebook.
Okay, you guys are going to ask for help a lot in the next 2 days. And
It's okay.
okay, so what percent of the data is between 100 and 130? I'm going to use orange this time, but you can switch up your color. So I want to start at 100, and I want to go to 130. So I'm starting at that 100, and I'm going to go all the way up to 130. And I want to know between that amount. Subtract them? We add them. We're counting.
Oh yeah, I was thinking of subtracting one from me.
That's all right. So in this one, we're going to add them together. So 34 plus 13.5. 47.5? Promise? Okay. We had 2 people who did it, so I trust you guys. All right, 47.5%. All right, we have one left. This next one, the first thing we're going to do is figure out what is our mean and our standard deviation. So remember, mean is the same thing as that x bar. And SD for standard deviation. So in this next problem, how can I find that mean? Mean is going to be that middle, the tallest point, where the mode is in a normal curve. And we get 36. Alright, now I know some of you already worked ahead and you already figured out your standard deviation. Give us everyone else a second to breathe that through. Okay, if I need to figure out what I'm adding or what I'm subtracting, if I don't know the answer, how could I figure that out? We could subtract 2 of the numbers, and we're going to subtract the ones that are next to each other. So we could do 43 minus 36. Whoa. So we should be adding 7, and we can just double check that. 43 plus 7. Yep, that's 50. 50 plus 7 is 57. If I went the other way, if I accidentally did 36 minus 43, what's going to happen? Negative 7, and then we just know it's 7. Yep. Good. Our standard deviation will always be a positive, so we should be adding and subtracting 7 is our standard deviation. All right. Last question for our notes to round out this year. Aww. Last example of the whole year. So sad. What percent of the data is greater than 29? Okay, there's going to be one question on your review today that's going to ask you to do this type of question, and it says, hint, draw it out. That means to actually draw a normal curve, label it out, and then so you can find your percents. Okay, so I'm looking at greater than 29. So I'm going to start at 29, and I want everything bigger than that. So I'm going to go all the way to the end of that curve. So there's a couple ways to do this one, depending on where your brain's at and how you're thinking about it. One way is to think about each of these standard deviations as their individual amount, which we already wrote down those individual amounts on top, so that'll be easy to copy. This would be 34%. This is 34%. 13.5. 2.35. And 0.15. And we're just going to combine those all together. So we could write that out. 34 plus 34. No, you'd have to write 2 times 34. 34 to the second would be, yeah, that's a whole big number. 13.5 plus 2.35 plus 0.15. So that's one way to do it, is to add each individual bar. Another way that might be easier for some of us to think about it is where that yellow line is. Where is our yellow line? Where does that mean? It's in the middle. Yeah, so everything shaded to the right of that, if the whole thing is 100% and this cuts it in half, how much is this? And half of 100% would be 50%. So we could take that 50% and how much more am I going to add on to it? An extra 34%. Okay, if that makes sense to you, you can always do it that way, thinking half the graph is 50%. If you're like, where the heck did that 50% come from? Why is that 34 there? Just add each individual one up, you get the same answer. It's a little bit more work, but you'll get the same thing. Okay, and 34 plus 50 is 84%. Of our data should be bigger than 29. Congrats, you finished your notes for intermediate algebra.